Hello everyone. This is the worksheet on the topic of the sampling distribution of the sampling mean. Now I hope you've all watched the lecture video on this topic. Now we are going to work through some questions related to that chapter. Now if you recall from this chapter on the sampling distribution, we had come up with some theories about the mean of all the sample means and also the standard deviation of all the sample means. All right. So keep in mind, we are no longer dealing with individual observed values. The values that we are looking at from now on is the sampling mean, all different sampling mean values from that come up theoretically from a study if we were to work on every possible sample from a population. Okay. Now, just let me take out my pen first. Now, the two particular formulas that we had derived from this chapter was about the mean of all the sample means, and we said the mean of all the sample means will always equal the population mean regardless of the sample size, of n. However, the standard deviation of all sample means will be dependent on the size of the sample we are using, and that goes by the formula population standard deviation divided by square root over n. That's the formula for the standard deviation of all sample means. So the sample size does have an effect on the standard deviation of sample means. However, the mean of all the sample means is not affected by the sample size. So let's look at some of these questions here. The first one says, does the sample size have an effect on the mean of all possible sample means? Explain. So as we see over here, the mean of all sample means equals to the population mean regardless of what the sample size is. So here they are asking about the mean, so we must say that no, the sample size does not have an effect on the sample mean, does not have an effect. So to speed it up, I just paused and wrote out the answer here, and I'm going to read it out. It says, no, the sample size does not have an effect on the sample mean. For any sample size n, you have to explain, all right? This is important, and we have to explain it using the statement, for any sample size n, the mean of all sample means equals the population mean. So you have to write the formula here in notation form. Mu of all sample means the mean of all sample means is always equal to the population mean. All right, so this will be a complete answer to the question. Let's look at the next one. Question number 2 says, does the sample size have an effect on the standard deviation of all possible sample means? Explain. So this time they're asking about the standard deviation, and we learned from this chapter that the standard deviation of all sample means is influenced by the sample size that we are going to use, and therefore the formula also factors in the sample size. The formula is not the sample mean, but the population mean divided by the square root over the sample size, or n. So to write it, to phrase it, the answer should be yes. Larger the sample size. First of all, you have to say yes, the sample size has an effect on the standard deviation, and that larger the sample size, smaller is the standard deviation. All right. So I'm going to write out the answer. I'm going to pause it, pause the recording, write out the answer, and then come back and explain one more time. So here is the complete answer. The answer should be phrased as yes. The sample size does have an effect on the standard deviation of all possible sample means, which is sigma sub x bar. Larger the sample size, smaller the standard deviation from the population standard deviation. The spread of the sample means become smaller as the sample size increases. So that means the sample size, or let's say the standard deviation, is inversely proportional to the sample size. Okay, let me rephrase it. The standard deviation is inversely proportional to the sample size that we use. That means larger the sample size, smaller is the standard deviation. Smaller the sample size, larger is the standard deviation. Okay? Now the next question is asking, explain why increasing the sample size tends to result in a smaller sampling error when a sample mean is used to estimate a population mean. All right? So keep in mind that as the sample size increases, but once we start increasing the sample size and get closer and closer and closer to the population size, what is going to happen? There's going to be less sampling error. That means the difference between the sample mean and the population mean is going to get smaller. All right. So what it says here is this is because as the sample size increases, one gets closer to the population size. So there is less sampling error. And what we mean by that is that the sampling mean and the population mean are going to be closer in value. If the standard deviation of x means the particular variable that we are studying, if the standard deviation of x is sigma, then the standard deviation of the sample means is proportional to sigma over square root over n. In other words, the population standard deviation over the square root of the sample size, and therefore increasing n has the effect of reducing the standard deviation of the sample mean. So mathematically, if we have a very large value in the denominator, then the result of this quotient, all right, the quotient is going to get smaller and smaller, correct? So that is the reason why mathematically speaking, why the standard deviation gets smaller. Standard deviation of all the sample means gets smaller as we increase the sample size. In this question, we can go through an exercise of showing that the mean of all sample means is going to be the same as the population mean of individual variables. All right. So this particular question is about NBA champs. The winner of the 2008-2009 NBA championship was the Los Angeles Lakers. One starting lineup for that team is shown in the table below. So we have the names of 5 players. So to make it simple, since this is for a learning experience, they've given us only 5 data sets. So the population size is 5, and these are the names of the different players, their positions, and then their heights. And they just use some initials here. For Trevor Ariza, it's T. For Kobe Bryant, it's K, and so on, so that it's easy for us to work with through the problems. All right, so and then we have the heights of the players in inches. So the variable that we are studying here is heights of different players in the Lakers team. Now the first question is, determine the population mean height mu of the 5 players. So that's the first exercise. So we are trying to find the population mean. Again, the formula for the population mean remains the same. So let's write that down here. Okay, so it's sigma x, right? So mu is going to be equal to sigma x, sum of all the values of the variable, sigma x over capital N. Because we are dealing with the population mean here, I'm going to use the uppercase N as the notation for the population size, right? Uppercase N denotes population size, the lowercase n denotes the sample size. So we are doing is we are listing, let's write that down, mu equals sigma x over n. So just sum up all the heights, which is 80, 78, 84 plus 73 plus 84 divided by 5. So the sum of all these values is 399 over 5, which is equal to 79.8 inches. 79.8 inches. All right, so that's the population mean heights. Now in the second part of this problem, they tell us to create samples of size 2. So for samples of size 2 without replacement, find the mean mu sub x bar. That means the mean of all the sample means of the variable x. So first we have to create samples of size 2 from the population of these 5 players. So I'm going to use the tree method that I had demonstrated before to come up with all combinations of size 2 from a population size of 5. So let's go through the tree method. I'm going to use these letters to denote our players, and let's list that. It's T, K, A, D, and P, right? These are the initials. And I'm going to start with T. So this is going to be a review of how to come up with all possible combinations using the tree method. All right, so T, start with T in the first draw. Let's say in the first draw we got a T, and then in the second draw, now we only need 2 draws because our sample size is 2. So in the second draw it can be K. We can either get K or A or D or P, correct? And let's list these combinations. So TK, the first one is TK, next one is TA, right? I'm walking the tree here, TK, TA, TD, TP. So TA, TD, and TP. All right, now in the next tree, we start with K. So I'm going to write here K. And after K, we can either get A, D, or P. So A, D, and P. And let's list them up in column 2 here. So it's going to be KA, KD, and KP, correct? And now we start another tree with A this time. So A. So after A in the second row, we can either get a D or a P. So AD and AP. And then finally D, right? So DP. All right, so after D, there's only P. So that's the only combination we can get after D. So DP. And let's number these samples. 1, 2, 3, 4, 5, 6, 7. So we have 10 possible combinations of size 2 from a population size of 5. Now we have to find the sample means for each sample. So the first sample has T and K, so we take the heights of T, which is 80, and K is 78. So 80, 78, 80, 78. So to find the sample mean, it's going to be 80 plus 78 divided by 2, correct? So that's going to be 79.0. Then we have TA would be 80, 84. Those two values, we have to find the mean of those two values. So that would be 82.0. So I'm going to complete this and come back, all right? Instead of spending time going through the entire list, I will pause the recording, complete the table, and we'll come back. So we have listed now all the heights for each of these samples and then calculated the mean heights. We have to now find the mean of all the sample means. So add up all the values in the last column and we should get sigma x bar. All right, so the last column is all x bar values, correct? So when you sum them up, we get a total of 798. And now we have to find the mean of all the sample means. Just a second. I have this number disappearing. So 798. Okay. So find the mean of all the sample means. When we find that, it's going to be mu sub x bar is 798. All right, you add up all the sample means, which is 798 in this case. And how many different samples do we have? 10, right? That's the list of all possible samples. You cannot leave out any. So 798 divided by 10 is 79, equals 79.8. And does that equal what we found for the population mean when we added up the individual players' heights and divided by the number of players? Yes, 79.8, correct? So we got the same value, and that proves that the mean of all sample means is equal to the population mean regardless of the sample size. If you had done this calculation using a sample size of 3 or sample size of 4 or sample size of 5, you would still get the same mean of the sample means. All right, it would be 79.8. So part C says find the mean of all the sample means using only the result of part A. That means they are asking you to use the axiom, the fact that we had learned, the theory that we had learned, that the mu of all the sample means is equal to population mean. So if we know the population mean, we do not even have to go through this calculation, this exercise through this table. We can just say that the mean of all the sample means is going to be equal to 79.8, which is the value of the population mean, which we found in part A of this problem. All right, so this is how you're going to work through a problem which asks you to kind of demonstrate that the mean of all the sample means is equal to the population mean. Let's look at the next problem on sampling distribution. I'm going to first read through it. It says, according to the Bureau of Labor Statistics, self-employed persons with home-based businesses work a mean of 25.4 hours per week at home. Assume a standard deviation of 10 hours, and then we have some follow-up in questions based on the information provided here. So first, let's extract the data from the question. It says it's a study on the hours that self-employed persons work with home-based businesses, the hours that they work from home or work at home, and that's 25.4 hours, the mean. And these are all the population mean metrics. So these are the parameters. So let's take out our pen again, and the mu value, which is the mean, the population mean, is 25.4 hours, and the standard deviation is 10 hours. All right, so the standard deviation value is 10 hours and the population mean value is 25.4 hours. Question is, identify the population and the variable. So let's identify first what the population is. Population is self-employed persons with home-based businesses. So let's write that down. Self-employed persons with home-based businesses. With home-based businesses. And the next part of the question asks, just a second, business. And the next part says, what is the variable under study? So what are we studying here? Hours, correct? We are studying the hours worked at home per week. So hours per week worked at home. Part B says, for samples of size 100, find the mean and standard deviation of all possible sample mean hours worked per week at home. So this time we do not need to build tables or work through a table. We are just going to use the facts and formulas that we learned previously on the sampling distribution of sample means and apply those to solve these problems. So for samples of size 100 means n, the sample size is 100, and first we need to find the mean of all the sample means. The mean of all the sample means, we know by now, is equal to the population mean. And if they've given us the population mean at the beginning of the question, that's 25.4, that the mean of all the sample means is not affected by the population, by the sample size. Whether the size is 100 or 1000 or 10, doesn't matter. The mean of all sample means is always equal to the population mean, and that's 25.4 hours. All right. They've also asked us to find the standard deviation. Now, the standard deviation of the sample mean has a formula, which is the population standard deviation divided by square root over n. You have to know this formula. When we are working with sample means and asked to find the standard deviation, then it's the population standard deviation divided by square root over the sample size. And keep in mind that the standard deviation is affected by the by the sample size, and that's why we have n in the formula. So sigma here is 10 hours, correct? Standard deviation, population standard deviation is 10 divided by square root over 100. So 10 divided by square root over 100 is 10, which is 1 hour. All right. So the answer to this question is that the mean of all the sample means is equal to 25.4 hours, and the standard deviation is 1 hour based on this formula we used. All right. So how do we write the interpretation? All right. What do we write for the interpretation? I'm going to write it out first and come back and read it out. All right. So how do we write the interpretation? The mean hours per week worked at home by self-employed persons with home-based businesses with samples of size 100. I missed a zero here. With samples of size 100 is 25.4 hours and the standard deviation of 1 hour. Now, it's very important to be precise when doing the interpretation. Over here, I've written out it's the mean of what? It's the mean hours per week worked at home by self-employed persons with home-based businesses. So this mean does not include those who do not have home-based businesses. Right? So you have to be precise in your interpretation, otherwise you will mislead the person who is reading your interpretation. Okay, and also specify the size, because the size, even though the size does not influence the mean, it does influence the standard deviation. All right, now part C is using the same problem, the same context, but this time they are asking us to use a sample size n of 1000. Right, so let's go on with this one. N is 1000 for part C. So let's calculate the mean of all the sample means first. So mean of all the sample means equals population mean, irrespective of what your sample size is. So we're just going to write the mean of all the sample means is equal to 25.4 hours. It will not be affected by the sample size you are using, the mean. The sample mean, the standard deviation rather, is what I meant to say. The standard deviation of all the sample mean is going to be calculated using the formula sigma over square root over n, which is, what was sigma? 10 divided by, this time it's square root over 1000. All right, 1000, that's the sample size we've been asked to use. So that's 10 over square root over 1000 is roughly 31.622, which gives us a value of 0.316 hours. All right, and again you are going to write the interpretation, and let me write that and come back. So the final interpretation is the mean hours per week worked at home by self-employed persons with home-based businesses with samples of size 1000. You have to specify the sample size is 25.4 hours and the standard deviation of 0.316 hours. And if you go back, you will see that the standard deviation of the size, when we use this a sample size of 1000, we have a smaller standard deviation than what we had when we were using a sample size of 100. So as the sample size increased, the standard deviation got smaller. All right. Now this problem is similar to the one that we worked before for question number 5. So I want you to do this yourself, and I'm going to just write the answers, come back and check if your answers agree with mine. All right? So here are the answers. Let me just write it down first, and then you can come back and look it up. So for a mean of $65,100 as the price of new mobile homes, and given a standard deviation of $7,200 for samples of size 50, the mean of all the sample means should be 65,100, and the standard deviation is going to be 1,118.39. You have to do some calculation for the standard deviation, as you know, and then the interpretation should say the mean price of new mobile homes for sample size of 50 is $65,100, and standard deviation is $1,018.39. And then when we are using a sample size of 100, the mean of all the sample means still remain the same, but the standard deviation has a value of $720. So as we increase the sample size, the standard deviation did decrease from 1018 when we were using a 50 for our sample size to 720 when we increased it to 100. All right, and then the interpretation should be the mean price of new mobile homes for sample size of 100 is 65,100 and standard deviation of $720, right? So that completes all the questions in worksheet 7 on the first part of sampling distribution of the sample mean. There's another one which I will go through in a video demonstration, right?